7B94A. Line 22, 7B94A. Green's function, part 1, linear equations. I have to make it 94A. Well, I'm not going to make it 94A because it makes the line too long. I just did 94A just so it's the same number. So there's the alien radio signal. Push it out of there. So this is a linear time-invariant systems green function waveform signals for communications UFO spaceship found in WOW data. So July 8, 2013 was when I was working on it. Today's July 13th. Green's function is a theory, yet the WOW data brings up a formula that talks about r to the power of 100 creating velocity in line 17t. There's 17t 2b up to 4b, but the actual formula isn't 4b. Came up in the formula from a previous video, creating a formula in it, line 22, 7B91, Aharonov-Bohm Oscillations Quantum Dots Formula 5G Wow Seti. So the quote from wiki is, in mathematics, a Green's function is the impulse response of an inhomogeneous differential equation defined on a domain with specified initial conditions or boundary conditions. Via the superposition principle, the convolution of a Green's function with an arbitrary function fx on that domain is the solution to the homogeneous differential equation for fx. Linear partial differential equations, Green's functions, are studied largely from the point of view of fundamental solutions instead. Under many-body theory, the term is also used in physics, specifically in quantum field theory, aerodynamics, aeroacoustics, electrodynamics, and statistical field theory, to refer to various types of correlation functions, even those that do not fit the mathematical definition. A Green's function, gxs, of a linear differential operation, L equals Lx, acting on distributions over a subset of the Euclidean space Rn at a point S, is any solution of. And there's the formula where there's a symbol is the direct delta function. This property of a Green's function can be exploited to solve differential equations of the form, and there's the equation there. If the kernel of L is non-trivial, then the Green's function is not unique. However, in practice, some combination of symmetry, boundary conditions, and/or other externally imposed criteria will give a unique Green's function. Also, Green's function in general are distributions, not necessarily proper functions. Green's functions are also a useful tool in solving wave equations and diffusion equations. In quantum mechanics, the Green's function of the Hamiltonian is a key concept with important links to the concept of density of states. As a side note, the Green's function, as used in physics, is usually defined with the opposite sign, that is, that. This definition does not significantly change any of the properties of the Green's function. If the operator is translation invariant, that is, when L has constant coefficients with respect to x, then the Green's function can be taken to be a convoluted operator, that is, this symbol thing here. In this case, the Green's function is the same as the impulse response of linear time-invariant system theory. My thoughts. The keywords from Green's functions. Green's functions are also a useful tool in solving wave equations and diffusion equations. So impulse response of linear time-invariant system theory, part 2, continues in our next video. Thanks for watching.